Morning, everyone. Here's our second review YouTube video. And our second review YouTube video is on polynomials. Now, to be totally honest with you, the polynomials review and the concept of expanding and factoring is probably one of the most important concepts in your high school math career. Okay, factoring is essential in every single course, and so is expanding and simplifying. So this is one unit that you definitely want to have a good handle on. So let's take a look at it. We started the unit with adding and subtracting polynomials, and the rules are: remove the brackets using the distributive property, rainbow, and collect like terms. Now, when you're collecting like terms, the terms must be identical. And remember, in class, I talk about identical and collecting like terms with the idea of the Pokemon and Yu-Gi-Oh cards. Okay, I call it Poke-Yugi. So like terms are terms that have the exact same letter and exponent. Okay, let's take a look at what we're going to do here. Our first example, we have a 9 outside of the bracket, and I'm going to rainbow that 9 in. And when I rainbow that 9 in, I'm going to end up with 9a plus 18b, minus 9c plus 27a minus 9b. So I've expanded. That step is called expanding. Now I'm going to do what I call the Poke-Yugi. You're going to collect all the A's together, sort of like putting them in a pile, like when you're collecting cards, all the B's together, and all the C's. So 9a plus 27a is 36a. 18b minus 9b is 9b, and the lone 9c. That is your classic expanding and simplifying. First step being expanding, second two steps being simplifying, collecting like terms, and in layman's terms, I call it Poke-Yugi. Okay, let's take a look at the next one. I'm going to expand. So 4 goes with the x, 4x, 8y minus 4z. Now be careful, this is often a silly for most students. That negative 3 is going into or expanding into the second bracket. So minus 6x plus 9y minus 3z. So the 4 gets expanded or rainbowed into the first bracket. The negative 3 gets expanded or rainbowed into the second bracket. Now I'm going to collect like terms. All of the x's, all of the y's, and notice when I'm collecting like terms, my sign is not changing whatsoever. So 4x minus 6x, 8y plus 9y, negative 4z minus 3z. 4 minus 6, 8 plus 9, negative 4 minus 3. Expanded, simplified. That was our first lesson. Our second lesson dealt with multiplying a binomial times a binomial. So hold on, let's discuss what we mean by a binomial. A binomial is a set of brackets in which there are two terms inside the bracket. Another binomial is a set of brackets in which two terms are enclosed inside the bracket. Both are known as binomials, and they're both being multiplied. Now, when you're multiplying two binomials, you cannot use the rainbow technique. The technique that is used is called FOIL. first times first, outside times outside, inside times inside, last times last. So let's take a look at our few examples that we've got here. Our first example has a binomial that's being quantity squared. When I see that, I immediately want to write it like this. Because when I immediately write it like that, I see a binomial times a binomial, which says to me, first times first, x times x, x squared. Outside times outside, x times 5y. Inside times inside, 5y times x. And finally, last times last, 5y times 5y. Now it's time to clean things up. So are there any other x squareds? Nope. Are there any other xy's? Yes, there are. 5xy and 5xy gives me 10xy. Are there any other y squareds? No, there's not. Expanded using FOIL, simplified by collecting like terms. Okay, let's look at our second example. Now, our second example, hold on, let's take a quick look at it. Our second example has a monomial, a constant value of 2, multiplied by 2 binomials. So what I want you to do is I want you to leave that 2 out in front. Okay, I want you to leave that 2 out in front, and notice how I started with the big brackets. Now what I want us to do is I want us to cover up that 2, and I want us to FOIL. First times first, k times 3k. Outside times outside, k times negative 5. Inside times inside, 4 times 3k. Last times last, 4 times negative 5. So 3k squared minus 5k plus 12k minus 20. Now what I want you to do is I want you to actually rainbow in the 2 to each of the terms. 6k squared minus 10k plus 24k minus 40. So 2 times 3k squared, 2 times negative 5k, 2 times 12k, 2 times negative 20. Are there any other k squareds? Nope. Are there any k's to collect? Sure there are. Negative 10 and positive 24k. Are there any other numbers? Beautiful. So expand, expand, simplify. So we expanded using FOIL, we expanded using rainbow, we simplified and collected like terms. Okay, the last example is probably our hardest one yet because it's got a mixture of everything. Okay, so hold on. The other important part that I want to mention is when you're reading an expression in math, you don't jump right over here. Your eyes always work from the left to the right, just like you were reading. So 3's going to rainbow into the binomial. 3a minus 15. Now, if I start looking at this, I've got a negative 1 sitting in front of this bracket. So what I'm going to do is I'm going to leave that negative 1 out in front, just like I left the 2, and I'm going to FOIL the contents of the bracket. Notice how I'm covering everything up with my finger. First times first, 7a squared. Outside times outside, 28a. Inside times inside, negative 2a. Last times last, negative 8. So notice I did the exact same thing with the negative 1 that I did over here with the 2. I left it out in front and I did my foiling. We're not done expanding yet, guys. That negative 1 has to be brought into the bracket. So hold on. The 3a stays the same. The negative 15 stays the same because I'm reading from left to right. Now I'm going to rainbow in that negative 1, negative 7a squared, negative 28a, careful, plus 2a, careful, plus 8. So when I rainbow in that negative 1 to each of those terms, notice how the signs have changed because of that. Guess what? Now I'm going to pokey-oogie. Now I'm going to collect like terms. I'm going to start with my a squareds because we always put our powers in descending order. Okay, now I'm going to put down my a's. Positive 3a minus 28a plus 2a. Notice there's no sign in front of the 3a, but if there's no sign, the assumption is that it's positive. Now I'm going to write my numbers. Negative 15 plus 8. So negative 7a squared, careful. 3a minus 28a is negative 25a. Negative 25 plus 2 is negative 23a. Negative 15 plus 8 is negative 7. Beautiful. This is the polynomial review of expanding. Expanding using rainbow, expanding using FOIL, a combo of the two, and then a collecting of like terms. The collecting of like terms is called simplifying. That's you simplifying the expression. And remember, simplifying just means cleaning it up. All you're doing is tidying it up. You're cleaning it up. Okay. This was the first part, and you're going to see some of these questions on task B, things that are similar to this, okay? All right, let's flip when you're ready. Now, the second page of your package, I made it like a tree diagram, okay? And I hope this helps you. And the reason I made it like a tree diagram is when you're factoring, okay, the first thing that you do is that you always look for something common first. But the type of factoring you're going to use depends on how many terms you have. Are there 2 terms in the question? Are there 3 terms in the question? Or are there 4 terms in the question? So let's start specifically with 2 terms, okay? If you sit down to your task and you get a question with 2 terms, that question can either be a common factoring question or a difference of squares question. Okay? So let's look at our first example. There's 2 terms, 16x squared and 32x. 2 specific different terms. First thing I ask myself, is there anything common? Is there anything common with the numbers? Yes, there most certainly is. 16 is common. Is there anything common with the letters? Yes, x is common. So if I factor out, if I divide out, if I pull out 16x, what will I have remaining? X. Now hold on. 16x plus x gives me 16x squared. Okay. 32x, and if I factor out 16x, I'm left with 2. Let's double check that, guys. Let's just mentally double check that we're right. 16x times x is 16x squared. 16x times 2 is 32x. Beautifully done. Okay. Now, let's take a look at this example right here. Some of you are going to look at this example and say, hey, Ms. Martel, I see more than 2 terms. You really don't, though, okay? This big lump of a term is a big lump of a term. And this is also a big lump of a term. So let me ask you something. Do you see anything common there? Well, the brackets are kind of matchy-matchy. They're not identical, but they're kind of matchy-matchy. Could we make them matchy-matchy? Whoops. Sure we could. Now let's watch. See this bracket right here? I would be a lot happier if it was -2 and if that was positive x. It would be if you change this sign right here and you factor out a negative. So if I pulled a negative out of 2, and if I pulled or divided a negative out of the negative x, look what just has happened. So instead of having this be a +4, if I made it a -4, which meant that I was factoring out a negative out of the contents of the bracket, look at how the brackets are matchy-matchy now. +x, -2. Now you have a classic common factoring. The only difference is that what's common happens to be this block. So pull out what's common, pull out the block, pull out what's common, and then what do you have remaining? 3x minus 4. Two-termed question, two-termed question. Yes, it's an uglier two-termed question. I agree with you. Okay, I'm not even going to argue with you on that. It's definitely an uglier two-term question. It's harder. This one's harder, way harder. But it factors beautifully. Now, let's compare it to these 2 examples. 2 terms, 2 terms. But when I look at 25 and 16, there's nothing common. When I look at a squared and b squared, there's nothing common. Same with this example. Absolutely nothing common. So common factoring does not apply to these 2 examples. But what does apply is difference of squares. Let's think of the requirements of difference of squares. 2 terms, perfect square. 25 is a perfect square, a squared is a perfect square. 16 is a perfect square, b squared is a perfect square. So 2 terms, both are perfect squares with a subtraction sign. Let's look at the other example. 2 terms, 81 is a perfect square, so is m to the 4 with a subtraction sign. Both of these questions meet the guidelines for difference of squares. Now, as soon as you know that it's a difference of squares question, we're going to go bracket, 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 and listen to my verbal steps. Square root of the first term, 5a. So square root of 25 is 5, square root of a squared is a. Square root of the second term, 4b. Square root of 16 is 4, square root of b squared is b. Finish it off with a plus and a minus. Question is done. Perfect. Let's do the next one. Square root of m to the 4. Now, let's do a little bit of side work here, okay? I know that the square root of m squared is m. But what about if I asked you to take the square root of m to the 4? That's m squared. What about if I asked you to take the square root of m to the 6? What would you guess? What would you guess that would be? Divided by 2, divided by 2, m to the 3? What if I asked you to take the square root of m to the 10? Divided by 2, divided by 2, divided by 2, m to the 5? So the square root of m to the 4 is m squared. That's the square root of the first. Square root of the second is 9. Let's finish it off with a beautiful plus minus. Now, what if I told you that you're not done this question? And the way that you would potentially know that you're not done is I'm going to tell you that that question's worth 3 marks. So if I'm telling you the question's worth 3 marks and we've only done one step, that's a really good indicator like, I'm not done. So where am I not done? Well, let's take a look at the contents of each of these little brackets. I've got 2 terms, perfect square, but it's a plus. I've got 2 terms, perfect square, with a subtraction sign. Guess what? This is a double difference of squares question. Because this second bracket right here is a difference of squares again. Square root of the first is m. Square root of the second term is 3 plus minus. Again, both of these final examples are way harder. I'm not going to lie to you. Both of them are way harder. But they're just using the rules that we have used. Okay? Let's take a look at 3 terms. What if we get to our task and all of a sudden there are 3 terms? 1, 2, 3. You always look for something common first. So if I take a look at this example, 18, 36, and 27. 9's common. Now look at the letters. A cubed, A4, A squared. A squared's common. B squared, no B's here. C cubed, C squared, no C's in all of them. So the only thing that's common is the 9A squared. So again, we're going to pull out, we're going to divide out, we're going to factor out 9A squared out of each of them. So 9A squared pulled out of the first term will leave me 2AB squared. 18 divided by 9 is 2. A cubed divided by A squared is A. B squared left over. Negative 36 a to the 4 c cubed divided by 9a squared is going to be 4a squared c cubed. And 27a squared c squared divided by 9a squared is going to be plus 3c squared. Again, classic common factoring question, classic 2 marks. 1 mark for the first term, 1 mark for the bracket. Okay, well, what if you get a 3-termed question, like these 3 examples, but there's nothing common? There's nothing common. Well, you might have what we call an easy trinomial. How do I know it's an easy trinomial? Because the number in front of that first term is a 1. That's what allows us to call it an easy trinomial. So with an easy trinomial, we create what I call the little product sum chart. And I'm going to draw the product sum chart for all 3 examples. The product in this case is 100, and the sum is negative 20. So when you think of the product, you've got to list all the options that multiply to 100. 1 and 100, 2 and 50, 4 and 25, 5 and 20, 6 doesn't go in evenly, 7 doesn't go in evenly, 8 doesn't go in evenly, 9 doesn't go in evenly, 10 does, 10 and 10. Of those options, how could I force them to maybe turn into a negative 20? Well, 1 in 100 is never going to happen. 2 in 50, 4 in 25, 5 and 20, 10 and 10 will work out if they're both negative. Negative 10 times negative 10 gives me a positive 100. Negative 10 minus 10 gives me negative 20. So my answer is going to be two beautiful brackets, y minus 10, y minus 10. Now, your answer could be written a little bit more mathematically efficient, okay? That's right, but it's not written as efficient as it could be. Most efficiently, y minus 10, quantity squared. Beautiful. Okay, let's take a look at the next one. Product's going to be 24. Sum's going to be negative 11. So think of all the options with me. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Of those options, can any of them turn into a negative 11? Yeah. Negative 3 and negative 8. Negative 3 times negative 8 gives me 24. Negative 3 minus 8 gives me negative 11. Okay, I've got my magic combination. The only thing that's different about this question is, see how there's a b squared here and an a squared? That means that when we put our answers in the bracket with our magic combination numbers, okay, b and b, negative 3 and negative 8, we know it works. Just have to put in that little a to accommodate for that a squared. Okay, let's look at the last one. Product is 32, sum is 12. 1 and 32, 2 and 16, 4 and 8. 5 doesn't go into 32, 6 doesn't go into 7 doesn't go, 4 and 8. 4 and 8 multiply to 32, 4 and 8 add to 12. Excellent, there it is. But I got a little bit of a problem in this guide too. And my problem is that the first term is an x to the 4. That means that instead of x being your first term in your brackets, it's going to be x squared. X squared plus 4, x squared plus 8. All three examples are easy trinomials because they have a 1 in front of the first term. They're 3 terms. And I found my magic combo. For each of them using my product sum chart. What if the 3-termed question that you get, just like this guy right here, has nothing common? Take a look at it, nothing common. And it also isn't an easy trinomial. How do I know that it's not an easy trinomial? Because this number right here is not a positive 1. What do I do then? Well, this is what we call tricky trinomial. And a tricky trinomial also requires a product sum chart. And my product is derived from multiplying the coefficient of the first term times the final term. So my product is 40 and my sum is 22. Well, let's think of all of the options that multiply to 40. 1 and 40, 2 and 20, 4 and 10, 5 and 8. Of those combinations, can you force any of them to turn into 22? There we go. Now, instead of being able to take that magic combination and just put them in the brackets like you did with a simple try, you can't. You've got to do a process that we call decomposition. So hold on, watch me for a second. 8x squared plus 2x plus 20x plus 5. So notice what's happening there. I'm decomposing the 22x. I'm breaking it up. Notice if I collected like terms here, I would go right back to my previous step. Okay, let's group. What's common in the first grouping? What's common in my first grouping? 2x is common. If I factor 2x out of those terms, what will I have remaining? 4x plus 1. Okay, what's common in the second grouping? What's common in the second grouping? Positive 5. If I pull 5 out of those two terms, what will I have left? 4x plus 1. Now, if you look at the line that we just wrote together, I'll look at it and be so happy and so pleased, because look at the two brackets. They're matchy-matchy. They're completely common. What's common? 4x plus 1. And when I pull out what's common, what do I have left remaining? 2x plus 5. Tricky trinomial decomposition. Let's do another one. Let's do another one, because these can be a little bit challenging, okay? Let's do another one. So I'm going to create my product sum chart. And my product for this example is negative 60. And my sum is negative 7. Okay, so what multiplies to 60? 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 doesn't go in, 8 doesn't go in, 9 doesn't go in. Okay. Of these options, can I force any of them to turn into a negative 7? Sure I can. 5 minus 12. So there's my magic combo. 6x squared minus 5x plus 12x minus 10. Notice I'm decomposing. That's why this is called decomposition. Now I'm going to group. Look at that first group for me. Look at that first group. What's common in that first group? Well, the only thing that's common is an x. What will I have left? 6x minus 5. Take a look at the second group for me now. What's common? What's common in that group? Positive 2 is common. I could factor a 2. 2 is common to 12 and 10. 6x minus 5. Again, sigh of relief, happiness, because of the matchy-matchy. So what's matchy-matchy? And what do I have left over? When I pull the matchy-matchy out, what do I have left? Beautiful. Okay, so we've looked at 2 terms. We've looked at 3 terms. So common difference, common easy try, tricky try. What about if the question has 4 terms? Okay, well, it could be common factoring. Remember, we always try common first. So look at that first example. Do you notice anything that's common in all of those terms? M is. If I factor the m out, I'll have x plus y. Careful with the next one. 2mx, because I have m squared. One of them's coming out. 2m squared y, because I had m cubed and one of them is being pulled out, factored out, divided out. So 4 terms, it could be something common, or take a look. What about this question? Do I see anything common? No. So maybe it's grouping. Let's try this. Let's get my red pen going. And let's look at the first group. When I look at the first group, 4 is common, and so is x squared. So what will I have remaining? X minus 3. Now let's look at the next group. Careful with this sign. Let's pull out a negative 3. Whenever you have that negative there, it means that gives you the signal that you're pulling out a negative. X minus 3. I'm a little bit leery. Negative 3x plus 9. Okay. Whenever you're worried, all you have to do is pretend that you're rainbowing it in and see if you go back to your previous line. That's what's so great about factoring. Well, I'm feeling happy because my 2 brackets are matchy-matchy. They're identical. And what will I have left over when I pull it out? 4x squared minus 3. So 2 terms, 3 terms, 4 terms. Beautiful. Okay, let's flip to our last page. And on our last page of our review, before you get ready for your task, we're going to do what I call combo questions. And that means questions that are mixing, different types of factoring. So what I'd like you to do is if you could put this sheet over to the side. Okay, so I'm going to have mine over to the side. And I'm going to guide you through mentally how you should be attacking these questions. Okay? So if I look at this question, and I got my cheat sheet here, how many terms are in it? 1, 2, 3. So that means that I'm looking right here on my cheat sheet. First thing that I ask myself is there anything common? Yes. I know right off the hop that 4 is common. What about the letters? A is also common. Okay, so factor out 4a out of each of those terms for me. I'll have a squared, I'll have 3a, and I'll have 2. So notice I've used common factoring as the first step. But let me tell you a little trick. If I gave this to you on a test, or if I gave this to you on a task, it would probably say 3 marks over here. And that gives you an indication that I haven't done enough work for 3 marks. You know why? Because take a look, jump inside that bracket, and what do you see? You see 3 terms with nothing common, but those 3 terms that you're looking at, that's an easy trinomial. There's a 1 there. So hold on. Product of 2, sum of 3. Product of 2, sum of 3. Oh my God, there's the magic combo right there. What 2 numbers multiply to 2? 1 and 2 multiply to 2, but they also add up to 3. So 4a, a plus 2, a plus 1. There are your 3 marks. 1, 2, 3. So the combo that you were dealing with in this question was common factoring and easy trinomial. Let's take a look at the next one. And I'm going to give you a hint. You always look to the mark value. I'm going to give you a hint of 4 marks. Actually, sorry, my mistake. 3 marks. Take a look at it. Is there anything common with the numbers? Yep. Is there anything common with the letters? Well, A is common to all of them, and so is an X. So the first type of factoring that we used was common factoring. What will I have remaining when I factor out 2a? I'll have 6x squared plus 13x plus 5. Again, 3 marks tells me I haven't done enough. So jump in the brackets, and what do you see? 1, 2, 3 terms. But of the 3 terms, take a look at this guy. It's an x squared without the positive 1. So guess what? This is a tricky try. Product is 30. Sum is 13. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Can I get any of those to turn into 13? Yeah, 3 plus 10. So let's try it. This is going to be a beautiful decomposition. 6x squared plus 3x plus 10x plus 5. Let's group them. Well, what's common in the first grouping? 3x is common. What will I have left? 2x plus 1. What's common in the second grouping? Positive 5 is common. 2x plus 1. I'm so happy because what I ended up in my brackets is identical. So what's matchy-matchy? 2x plus 1. What's left over? When I pull the matchy-matchy out, what's left over? 3x plus 5. 1, 2, 3 marks. Beautiful question. Okay, let's pretend 3 marks. Well, this only has 2 terms. Okay, do I see anything common? Sure I do. 2 can come out. And what will I have left? 25x squared minus 1. And then when I look at the 3 marks, I think I haven't done enough work to get myself 3 marks. Jump inside the bracket. I see 2 terms with nothing common, but this guy's a perfect square, this guy's a perfect square, and it's a subtraction. So this is a common and difference of squares. Sorry guys, let's go back up and put tricky try. So when I do difference of squares, square root of the first, square root of the second, plus, minus. Okay, let's take a look at it again. 3 terms. Is there anything, 3 marks, sorry. Is there anything common? 20, 60, and 45. I'm going to try to take out a 5. 4x squared minus 12x plus 9. Okay, let's take a look at it. A common factored out of 5. I've got 4x squared, 12x. I know 4 can be taken out of those 2, but 4 can't be taken out of this. So there's nothing else common. But again, I see the 3 marks and I think, I need to do more than that for 3 marks. So kind of looks like I've got another tricky try with a product of 36 and a sum of negative 12. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. -6 and -6, my magic combo. That gives me my -12. So 4x squared minus 6x minus 6x plus 9. There's my decomposition. Now I'm going to group. What can I take out of the first group? 2x. What will I have left? 2x minus 3. What can I take out of the second group? Careful with that negative. -3. 2x minus 3. Wow, awesome. So what's matchy-matchy? And hey, look at this. What's left over? Oh my God, look at how neat that is. What's matchy-matchy is 2x minus 3, and what was left over was 2x minus 3. How cool is that? This is what we call a perfect square trinomial. How should I rewrite that, though? It's not written for best of final marks. It's not written most efficiently. Now it is, though, because 2x minus 3 can be written more efficiently as 2x minus 3 quantity squared. Okay, we're done with our review. I hope this review and this video helps you out to do your supplemental work and to do your task. And again, I'm going to say to you, this is a particular unit that you don't want to shy away on doing the homework. And if there's any problems, you need to let me know. This is a big, important topic. Okay? Hope this helps. Take care.